whiteboard. Whiteboard. Okay, there you go. Do you see the whiteboard?
Yes.
And the email I sent today, I sent to think. I sent the PowerPoint, okay, I want to discuss it now. And I sent the review for the test, okay? I suppose that today we have no time to start this. No, depending, no, I don't know. We are doing 2 word problems. We're discussing another topic, but it's super easy, super easy. And see, we have time, we start a little bit the review. Don't worry for this, because remember that we have one missing day, no? Because it's spring break, something. Now, you don't care this. When I finish the review, we are ready to take the test. Before, never, right? So don't worry for this. Let me try to all up the problems. Okay, there you go. This is my first problem. Do you see the whiteboard?
Yes.
Okay, this is about the famous Pisa of Tower of Pisa. Okay, you know, the most important is you understand a little bit, but finally we ending in one triangle, no? And you apply the law of sine or the law of cosine, depending on the case that we are working. Entonces, this is the original, the height, no, the length is 184.5 feet high. At the distance 123 feet from the base of the tower, the angle of elevation. So somebody get the instrument and measure the angle of elevation. Angle of elevation, when you hear the word elevation, is over. Angle of elevation is 60 degrees. Find the angle RPQ. RPQ is the angle of the inclination of this tower of Pisa. You know, it's a little bit inclination each year, a little bit more, a little bit more. And also find the perpendicular distance from R to PQ. R to PQ. Perpendicular distance is the height, the actual height of the tower Pisa. Okay, so now to understand much better this, well, actually the sketch is given the triangle, but just in case I want to do another triangle to represent my problem. This is the famous R. This is a P. This is a Q. And this is the distance I need to find. Let me call H, get the height. This angle of the elevation is 60 degrees, is given. This distance is 184.5 feet. Also, I need to find that angle. Okay, the angle is the angle that they call angle RPQ. Okay, this is the idea. Well, just in this case, we have one segment, one angle, but it's the opposite. This is good to apply the law of sine. How? Let me see. I put sine of the angle R. Get this angle. This is the angle R. Suppose sine angle R. Sine angle R divided by 123. Because this information is given, no? 223 feet. is equal sine 60 divided by 184.5 feet. Okay, therefore I can find the sine r. Cross multiplying sine r is a multiplication 123 multiplication sine 60 divided by 184. Okay, let's do it. Sine r is equal 0.5774. I'm going to find r to find the sine inverse. Sine inverse of 0.5774, and the answer is 35.3 degrees. This is this angle. But this is the angle that I don't want. Well, we have two possibilities, one in the first quadrant and one in the second quadrant, but the second quadrant have no sense because this angle is acute.
Professor, sorry, you forgot 0.5 on the sine of r, like on the fraction. You forgot 184.5.
You see this answer?
Yes, no, Professor, I'm saying like sine of r, you forgot 184.5. You didn't put.
Yeah, 0.5. Yeah, thank you. Okay, could you check in this result in your own calculator, or do you want I show you in my online calculator?
No, it's okay, Professor. I can check it here.
Okay. Let me know if you have some discrepancy. I checking in the calculator I have in my hand, or if you want, checking with the calculator online.
Okay.
The problem is the calculator online is different. It's a little bit complicated. There's no illustrate very well there. But okay.
Yeah, it gave me the same result, Professor.
Same result. Okay, now my goal now is compute this angle. But this angle is easy because it's 180 minus 60 minus 35.3. And the answer is 84.9. As a conclusion, the Pisa Tower of Pisa, the inclination is 84 degrees, almost 85 degrees. Okay, and what about the distant edge? Well, the distant edge, I propose you using this triangle. Using this triangle. Because this segment is H is perpendicular to this. So I'm using 90 degrees here. Therefore, it's easy. The trigonometric when the triangle is right triangle is super easy. Entonces now, what do you propose me? What trigonometric function you propose me using to find H? You using sine, que es opposite hypotenuse, cosine, que es adjacent hypotenuse, and tangent, que es opposite adjacent, no? What information we have in my hand? We have in my hand that the value, que es hypotenuse of this triangle, hypotenuse, and I need to find this guy, que es the opposite, to the angle, the famous angle that we compared before, que es 84.9 degrees, no? 84.9 degrees. This is this side I need to compare is the opposite, no? See, it's the opposite. So what do you see that the trigonometric function that I need to use it for this?
Fine.
Absolutely perfect. Entonces sine, wow, sine of the angle is equal h divided by hypotenuse, que es 184.5. Therefore, h alone is multiplication, cross multiply one more time. Cross multiply one more time is 184.5 times sine 84.7 degree. And the answer is 183.71 feet, que is actually the height, or the height of the Tower of Pisa. Not the length, sino the height, que is the distance from the ground to the peak of the Tower of Pisa. Any question? Entonces, in the word problem, we have no recipe, but we have a lot of formulas. Law of sine, law of cosine, trigonometry, basic trigonometry, que include right angle, and Pythagoras, and you're using your imagination. Entonces, I propose you, I bring in the PowerPoint 5 problem. I solving 2 only here with you. And the other problem is extra credit, 5 points for each. So 3 more, a 15 point total. Okay, and you send me with the reading test. No, now, in the moment the reading test, you send me the solution and you have 15 extra credit. Plus the 5 point of the my subscription and YouTube channel, as always. Okay, take advantage of this.
Can you repeat it, Professor? Sorry.
Yeah, we have today 5 problems in the PowerPoint. I want to solve it only 2, Nuela. The first and the second, that's it. And the other is extra credit. And you turn into me with the reading test. Okay? Okay. So far, it's not clear what is the due date for this test, no? Because I modified the syllabus, no? Remember, we have 1 day get missing, was missing for the spring break, something. You relax. You only pay attention and try to understand. Let's do in the second problem. Second problem. Second problem. This is the second. Okay, the second talking about is like a sky leaf, finding the length of the sky leaf. Wow. You have mountain, you have the famous device case called a sky leaf. You can see in the figure the length of the span of the proposed sky leaf, PQ, 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 PQ. And it's my goal, find PQ, no? A surveyor measure the angle of the elevation 25 degrees. So we have, okay, as always, we are doing our own triangle, no? To see more clear. Actually, we have no one. We have 2, no? We have 2 triangles like that. Boom. Okay, this is 90 degrees, I guess so. Okay, this is P, this is Q, and this is R. So what is the information that's given? Well, the surveyor measured the angle of elevation, que es 25. So this guy is 25. And then walk off the distance 100 feet. That distance is 100 feet. That distance, guys. And again, I suppose that the surveyor, again, take a look. What is the angle of elevation? Get 15 degrees. PQR, PQR, PQR. PRQ, PRQ. This is 15. What is the distance PQ? So my goal is find that distance. Let me put in the another color, orange maybe. This is my goal. Okay, by the way, this is D. More clear now the problem?
Yes.
Yeah, if you eliminate the mountain, you eliminate the tree, you eliminate some stupid details, they focus on the geometry part, and that's it. Okay, entonces in my opinion, I focus in this triangle. Okay, by the way, is obtuse because the main angle is greater down. So I can find why not this angle, because this angle is supplementary with 25. So the angle QPR is 180 minus 25 because it's supplementary, right? Makes sense or no?
Yes.
Yeah. And the angle PQR is this guy, and the angle PQR. Well, I know that the sum of any interior angle of the one triangle is equal to 180. Therefore, 180 minus 155 degree minus 50. And the answer is 10. It makes sense because it's a small triangle, 10 degree. Wow. So we have everything. We have three angle interior angle of this triangle. Good. I like that. And so I will be able to find any. And remember, my goal is PR, no? PR. What is the goal? What is PQ? This PQ. Okay, PQ and DQ and PQ. We need to find PQ. And we need to find complementary DQ. Que es the high of this. Pero this is the distance. Que es find the length of the sky leaf. Okay. I got it. So I apply, bueno, es obvio que yo apply the law of sine. Because the majority of information that we have is angle. How? Well, you find sine 10. Okay, sine 10 degree, que es this angle, divided by 1000, que es the opposite. It's super easy setup. Now sine 15 degree, the opposite is PQ. Makes sense, right? PQ. Now cross multiply. We have PQ is equal 1000 multiplication sine 15 degree divided by sine 10 degree. Put in the calculator, and the answer is 1490.48 feet. Okay, this is the length, that distance, no? That distance, let me see, that distance, PQ. Okay, I got it. That distance. Okay, complementary DQ, que es the high. It's easy. It's easy because I can use in the trigonometry. No log cosine is more complicated. No. The trigonometry of the right triangle. Entonces I don't know. I have no idea. Let me see. I need to find this. According to the 25, remember sine is opposite hypotenuse. Cosine is adjacent hypotenuse. And tangent is opposite adjacent, no? Okay, the information I have in my hand, when I have in my hand PQ, and PQ is the hypotenuse, right? Hypotenuse given. Hypotenuse given. And just automatically you discard tangent. I need to find opposite, because opposite of 25 is DQ. Opposite. Opposite. It's obvious que sine here. Sine what? 25 degree. Is the ratio between DQ and PQ. Therefore, DQ alone is PQ. PQ is 1,490.48 feet. Multiplication by sine 25 degree. All right. Now, put in a calculator, and the answer is 629.9 feet. Is the height of this sky leaf. Any question? Super easy or super complicated?
Professor, the thing that I didn't understand is why we chose like the angle that we are like looking at it is like from this first or the second triangle. That is the thing that I didn't understand.
Well, the reason is because the surveyor, I try to follow in the common sense, you know, surveyor, que say people, no? Stay here and measure this angle of elevation. And surveyor change to this. And again, check it, the angle of elevation in this position. And this information of the distance is given. Now, I try to understand that the most of information is about in the green triangle, not in the another triangle that is white color. Make sense?
Yes, it does. Thank you. I understood now.
Okay, guys, entonces number 3, 4 and 5, extra credit. 5 point.
Okay.
You try. I cannot help. You try with it. Si you cannot by yourself, go to the tutor, and you ask for help. Okay?
Okay, so Professor, it means that we're gonna continue to have like 105 points, but plus the extra credit, right?
Yeah, and you cumulate the point. Entonces, in the last test, you are doing nothing, or not nothing, pero you don't effort too much, you get the A, easy. Take advantage. Any extra point is good. Remember, this is arithmetic. I put in my spreadsheet Excel, and finally I average, include everything. Okay.
So Professor, another question. The final is not mandatory, right?
No.
Okay. And we just have one, or we have on the Alex as well?
No, only, no, Alex, no. Alex,
no, it's just on paper.
No. Alex, final is only written.
Okay.
In Alex, you have only 1, 2, 3, 4. That's it. Number 5 is reading optional for the student can need. And only reading in paper. Okay? Let's see now the formulas to compute the area for the triangle. One, okay. In geometry, we have a triangle. Look. Now my goal is compute the area. CAB. This is A, this is C, and this is B. Now in geometry we study that formula, no? The area. I don't want to put capital A like an area because it's confusing with this capital area. So you put area. That's it. It's 1/2 the base multiplication by the height. Who is the base? Well, the base maybe I suppose que es B or C or A. It doesn't matter what you select. Suppose que I assume que the base is B. And what is the height? The height is the perpendicular to the opposite vertex to this, 90 degrees. This is the height. Okay? However, I can apply, bueno, one trigonometric function. Can you let me know what is that? And this triangle. Que no necessarily is, this is a half. According to the figure, it look like, but no. In the geometry, you cannot assume the thing is not explicitly given. Entonces, in this, again, we have, suppose I need to find, my goal is find height. I don't know. I have the side, A, B, C, or the angle, whatever, pero the height no. Entonces, now, I know que sine is opposite hypotenuse, cosine is adjacent hypotenuse, tangent is opposite adjacent. Entonces, for example, if you want to find h according to, for example, this angle, okay, by the way, this is the angle C, no? Angle C, h is the opposite. And suppose que, well, I have no information about this segment, no, I don't know, but I know A, que A is the hypotenuse of this. Okay, entonces es obvio que sine of the angle C is equal h divided by A. Now I come back to the area formula. Area formula is 1/2 the base que I assume que es B, and the height que is A cross multiply here, h is equal A times sine. Entonces sine C. Wow, and this is my formula. My formula is, look, let me show you. Area, to compute the area for any triangle, one shortcut to do easy is, you put a 1/2, always 1/2. You multiply A and B. But not necessarily always A and B. And the angle in between A and B is C. Boom. This is the formula. We have another version of the formula, of course. You have another possibility que es area is equal 1/2. Suppose que I take A and C, sine B, que is the angle between A and C. Or another possibility, area is equal 1/2 B times C sine A. Okay? And this is super easy to remember, that formula. It's only 1/2 the multiplication of two sides and the sine, no cosine, the sine of the angle in between this side, B and C. Well, let's see one quickly example. This is super easy. Suppose we have that triangle. This is angle 30. This side is 6, and this side is 8. Compute the area. Well, just as multiplication, 1/2, don't forget 1/2, multiplication 8 times 6, sine 30 degrees. Area is equal 1/2, this is 48, and sine 30 degrees is 1/2 again, no? This is 48 divided by 4, because 2 times 2 is 4, is 12. Depending on the unit, see this is centimeter, for example. The area, okay, by the way, the area is the surface enclosed in the triangle, this surface. Es obvio que the unit is square centimeter. Boom, like that. Do you understand very well this? Easy,
Yes.
Easy. It's okay. Now we have another formula, a little bit more complicated. Que es, the name of that formula is Heron formula. Heron formula is applied when you have no information about angle. No angle. We have no angle. We have side. 3 three sides. You need to find the area. Of course, we can manipulate using law of cosine, and you find the angle. When you have the angle, you apply the formula, the previous formula. Pero no, okay. Let's do it in the another formula, que es area is equal big square root s minus a, x minus b, x minus c. And of course, ABC is given. For example, a 4, b 5 is given, no? And c is 7. And who is s? Well, s, by definition in the formula, is a plus b plus c divided by 2, sorry. Divided by 2. And that's it. Let's do it. So you compute it, for example, s first, que is 4 plus 5 plus 7 divided by 2. This is 9, 16 divided by 2 is 8. And now the area is equal square root a, que es s, a minus 4, a minus 5, and a minus 7. Area then is, this is a times 4 times 3 times 1. This is square root 96. Just is equal, well, leave it like that, 4 radical 6, and you want to express it in decimal. Let me try to put it in my calculator. It's 4 times radical 6. And the answer is 9.79. Okay, normally any answer you round to the near 10, 2 decimal place. Bueno, entonces no, entonces es 8, because the next digit is 7. Entonces 9.80. Okay. Okay, guys. So now, after that, I want to illustrate one topic is super elementary. It's important because in the test you have one question or two questions like that. Okay, the harmonic motion. Let me explain harmonic motion. Do you understand the formula for the area? It's clear?
Yes.
Okay. Now, another application of the trigonometric. Remember this chapter 3 and this chapter 4 is application. The thing we cover in the chapter 1 and chapter 2 is application. And physics is harmonic motion. What is that? Harmonic motion. It's easy. I have a PowerPoint to understand harmonic motion. Okay, harmonic motion. Where is harmonic motion? Okay, let me see. PowerPoint. No PDF. PowerPoint. Application logarithmic. There you go. Harmonic motion and weight. Okay, let's see the first slider, que es the animation. Oh, you don't see animation here. Oh, okay. No problem. Entonces now, much better. No, put it here in whiteboard. No. I open. No whiteboard. So I open in the application in the PowerPoint. Because it's animation, it's motion. Look, let me show you. PowerPoint. Harmonic motion, where? Harmonic motion. Okay, there you go. Okay, let me slideshow. Boom. And now, bueno, it's hard for me. Okay, try to share the screen. Screen share. Here, over there. Screen. Harmonic motion. There you go. Do you see the slideshow of the harmonic motion?
Yes.
Yes. Okay, okay. What is the harmonic motion? This is vibrational motion. Okay. Suppose the typical example, not necessarily the only one, is the spring, and we have a mass. Okay, the mass is the red ball. And you, for example, stretch the spring and release. Suppose que no power or no energy is lost, it's technical perfectly. Now the ball continues oscillation over and downward forever. Bam, 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 bam. This is a typical simple harmonic motion. And it's obvious que the equation of this trajectory look like no sine, look like cosine. Makes sense? And negative cosine, because start en negative, o sea, at t equals 0, que es now, we start amplitude negative 8. Negative 8. Okay? Entonces we have different parameters que I want to explain in one example to identify harmonic motion. One parameter is what is the maximum displacement, is A in this case, no? Positive A or negative A. What is the time required for the oscillation, o sea, the duration of the one period is the time of the one oscillation, and the frequency is the reciprocal of the period. Okay, I want to explain now. Okay, this is the harmonic motion. Okay, let's come back to the whiteboard to explain the equation in one example, and we continue the PowerPoint. Let me see. Whiteboard now. Do you see whiteboard? Suppose que in the test is given that situation. Displacement D is 10 cosine phi t. Maybe it's positive cosine or maybe negative cosine, depending the initial condition. So this is the equilibrium position for the spring. Si I, for example, stretch down, this is the spring. Si you stretch down the spring, es obvio que this equation, the displacement start at negative 10. But we can do in the opposite direction, no? Entonces positive 10 or positive whatever, positive 5. And you release, and the oscillation look like that or like that. Entonces now, depending the initial, si es upward or downward, positive or negative, right? This is the amplitude. This is the amplitude. So this A is called amplitude. Okay, by the way, it's a maximum. It's a maximum displacement from its resting or equilibrium position. Equilibrium position is when your spring have no force. Okay, no force, no compressing, no stretching. This is the spring and the normal length, equilibrium position. And you release, stretch or compress and start the motion. This is this maximum displacement. Maximum, this amplitude is equivalent to say maximum displacement. Good. The next question is maximum displacement. Second question is, what is the time required for one oscillation? This is called a period. What is the time required for one oscillation? One oscillation means, okay, you, for example, take the spring, move it down, complete one entire oscillation, and come back to the initial position. This is the time for this. And the formula is easy. The formula is Similar to the formula, the period that we studied when they are doing the graph of this is 2 pi over b. Now, who is b in our problem? Fi. And this is dependent, no? This is second. Because this phi is in radians per second. The unit of this is specificate. And number 3 is the frequency. Frequency es the reciprocal period. Entonces es phi over 2 pi. And where's the interpretation frequency? The period is the time for one cycle. Okay, let me try to explain this, the meaning, physical meaning of frequency. The period is the time is time per cycle. If you flip that, it's cycle per time. So the interpretation period is one. Okay, we have one cycle. This the time, the duration time of this. The interpretation for the frequency, no, is your specification one time, for example, 1 minute, or 1 second, or 1 year, and you count how many cycles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Suppose it is 5 over 2 pi, and this is oscillation per second. Oscillation per second. Make sense? Make sense? It's easy. It's only this information. It's one application that you see when you take. You took physics or not yet?
I won't need it.
You won't need it. Okay.
It's hard.
A little bit. Because basically it's the physics is the mother of the science.
It is very hard.
But okay, hard or easy is relative. It's up to you. The reason is because it's application or the thing that you study in your life, application for the real life. And basically the mathematics is the science that support the physics. Physics is the mother, mathematics is the sister of the science.
Maybe daughter.
No, not exactly. Okay, now we have well, this is ideal because in this case the energy, the mechanical energy, for example, when you stretch the spring, you apply potential energy. Okay, you know what is the energy when you stretch the spring? You have inside the spring the potential energy, because when you release, it automatically convert to kinetic. Kinetic means velocity, motion. It's the same principle that you apply, for example, in the R and the iron, and the pendulum, when you oscillate the pendulum on the antique clock, you have a pendulum, you move the pendulum in one specific height and you release and moving to the harmonic motion. But in this case, I suppose when you're talking about harmonic motion, we have no energy loss. So, you know, the energy convert from potential energy that you apply into the spring to kinetic when you release. And when you get, look, oscillation, one oscillation. At the beginning, harmonic motion. You apply one amplitude. Okay. And release. and I start like that. Right? In this case, you have potential energy EP maximum and kinetic energy 0 because it's at the rest. In this moment, when the spring is in the equilibrium position, the potential energy is 0, but it's maximum the kinetic because the velocity of the edge is maximum. The velocity here is 0. The velocity here is in that direction is maximum. And the velocity decreasing, and stop here, velocity 0. Again happen, kinetic energy is 0, but potential is the same. It's maximum in the opposite direction. That is the reason que si there are no loss of energy, this motion continues forever. It's a total ideal. In the real life, never happened like that. In the real life happen in this situation. You release and decreasing the amplitude little by little bit, you lose. And this is the damping motion. And the equation for the damping motion is a little bit different. Let me show you damping. Damping motion is you have a spring. This is the constant of the spring. This is the mass. And this together is harmonic motion. Now include extra element, que is the damper. Damper look like a piston. Okay, you see, for example, in the closer of the sun door in the Miami-Dade College, you see attached to the door in the back, we have one device called the closer. And the closer allow us, they give me the possibility to shut the door, but without oscillation, no oscillation. So now the motion, depending the damping parameter is, they are different behavior, no? But in this case, the most common behavior look like that. And what is the equation for the damper motion? Well, damper motion, the equation is displacement to any time is equal amplitude A, but you have exponential minus alpha t cosine omega dt. It's similar to harmonic motion, except that we have that part que es exponential. Bueno, this is physics. Omega d is square root omega null minus alpha squared. Omega null is square root k over m, depending the spring, depending the mass. And alpha no, depending the damper, que es b divided by 2m. And b is the coefficient of damper. That is the reason que you see compare the harmonic motion have no exponential. It's like that. Maybe cosine or maybe sine, depending. Harmonic motion look like that. For example, harmonic motion, nice. And damping, no. Damping stay here. Let me use another color. And we have lost energy. In one moment, stop. Okay, I have animation to illustrate this. You get the rough idea, no? No. You don't want to. I don't want to complicate your life because it's physics. Okay, but the idea is we have two kinds of motion: harmonic motion without damping. Damping equals 0, B 0, and damping motion is B have a damping. No. Let me try to share the PowerPoint I bring for you. I bring a PowerPoint. I bring the PowerPoint to illustrate this idea. Look, show you. Okay. Angelica, putting off your camera. I don't want to see your ceiling. Here you go. Do you see the PowerPoint? Do you see the PowerPoint? Yes or no?
Yes.
Okay, in the PowerPoint, let me try to explain. We have in black color harmonic motion. Harmonic motion never stop. Continue, continue, same amplitude, same amplitude. And damping motion is blue. You see how decreasing the amplitude little by little and stop in one moment. Do you see? Damping? Do you see the difference? This is the thing I want to illustrate. That's it. Now, this chart analyze also the combinations of the different weight, sine, cosine. You can interpret it like a weight, no? Okay. So in the PowerPoint, I illustrate also combining weight. Suppose, well, let me see. What happened, guys? See you adding two sine or two cosine with different frequency. With different frequency. Remember, frequency is amount of cycle per unit of time. Different frequency. Entonces now you see the result when you adding sine and cosine with a different frequency is periodic function, but non-sinusoidal. So the result is no sine, no cosine. It's non-sinusoidal, non. But it's also periodic. Periodic is okay. You see the repetition, right? Repetition. Another possibility, another combination of the function is this one, que es the typical application and modulation. It's in communication. You hear the phrase amplitude modulation or frequency modulation, no? So when you adding, this is important. Now you adding two sine or two cosine, and the frequency is similar, very, very similar. It is producing this effect. It's producing this effect. Okay, you see que it's interesting because the amplitude is increasing, decreasing, and increasing and decreasing. And this is modulation, amplitude modulation. Okay. I have another tool que I create to illustrate this idea, que es en Desmos. Let me try to show you Desmos. Angelica, putting off your camera.
Oh, I'm sorry.
No, it's okay. You don't know? Good. You putting off and you putting on again. Okay, Desmos. To illustrate non-sinusoidal periodic. Look, do you see Desmos now? Do you see Desmos? Do you see or no?
Yes.
Okay. Let me show you that part. In that part, we have, wow, look at that. We have one function sine, but let me start at the beginning. We have one function sine, tune. Okay, it's the frequency. I can change the frequency. If you want to look, frequency. Frequency, remember, is the amount of cycle per unit of time. I have another cosine. Wow. It's the same, right? Let me change the color, no? So sine is red color and cosine is blue. Okay, we have blue, cosine, and different frequency, no? Look, different frequency. And that's what is the idea? The idea is put together. So addition, plus. When you put plus, boom, wow. Let me erase sine, the original sine, the cosine. This is the idea. Okay, and you see the effect of modulation. Let me try to, for example, B I put like a 20 and D I put like a close to 20. Look, close to 20, close to 20, close to 20, close to 20, 19 point something. Ooh, do you see the effect of modulation? Si es 20, no. Pero when it's close, the sum of this is this modulation. Okay. Entonces, conclusion, when you add in two trigonometric functions, sine, cosine, or sine, and have different frequency, the answer is periodic but non-sinusoidal. It's another weird weight you never see in your life. However, if you adding, for example, in this example, one linear function, I don't know, one linear function, line, the famous line you know very well, and one sine, look, in green color, together is this, oh, in black color. So this, I delete the green, the sine, pure sine, and pure line. And the answer is, it's obvious que es non-periodic, and of course non-sinusoidal. But in this case, I combine non-periodic function, que es a line, with the periodic function, que es sine. And the answer is non-periodic. O sea, this is completely crazy, no? O sea, non-periodic combination con periodic give me non-periodic. And sine and cosine together is depending on the frequency. Si the frequency is different, the answer is non-sinusoidal. Non-sinusoidal. Si the frequency is the same, wow, what's happening if the frequency is the same? Okay, so my question is now, what should I do si I combine? Let me save this. If I bring another script, que is this? Okay, what is my goal now? My goal is I have two functions, sine and cosine. But the green color is okay. This is, you have two functions, sine and cosine. And you adding sine and cosine, and the frequency is the same. So what's happening? See, the frequency is the same. The amplitude, no. The amplitude I can change here, but the frequency is the same. So we can get generalized sine or generalized cosine. Look, let me show you. This formula is C. Who is capital C? Square root A squared plus B squared. And who is phi? Phi is tangent inverse of B over A, and phi 1 is tangent inverse of A over B. However, when you plot that, look, they want to prove mathematics in the whiteboard now. It's easy. I have application in physics also. Look, suppose this function. Bam! You see in black color, it's a perfect coincidence. The original is the green color. We are doing the sum phi sine x plus 7 cosine x. And the answer is that green function, okay, by the way, is periodic and sinusoidal. Perfect sinusoidal. No weird thing, modulation, no. Now, another possibility to express this is using generalized sine or generalized cosine. Look, let me show you. Boom. Black color, generalized sine. Or this, boom. Blue color, generalized cosine. You see it's the same thing? Let me explain in the whiteboard. Let's come back to the whiteboard. Do you see the whiteboard? Do you see?
Yes.
Let me erase the whiteboard. I want to explain the idea behind Generalize sine and cosine. Generalize sine and cosine. Okay, period. Okay, what is the idea behind this? And the idea is you adding, for example, 5 sine x plus 7 cosine x. And the answer is, I have no idea. Let's do in Bauer. Suppose que I have c sine x plus phi. This is a Greek letter, phi. I'm using the famous formula of the addition sign, que es c paréntesis sine x cosine phi plus cosine x sine phi. You now remove, apply distributive property, no? I have c cosine phi multiplication by sine x plus c sine phi cosine x. I want to call this guy like a. I want to call this guy like a b. Now we have a sine x plus b times cosine x. In conclusion, the thing I try to illustrate is that you can express the sum of sine and cosine in that way, que is the generalized sine or cosine. I want to play sine first, cosine secondly. Now, what is the relationship? What is the mathematical relationship? Well, c is a square root a squared plus b squared. And phi is tangent inverse of b over a. In our specific example that we discussed at the beginning, look, we compute this c sine x plus phi, like that. Who is c? Well, c is a square root phi squared plus 7 squared. 5 squared is 25, 7 squared is 49, put together, square root now 8.6. Entonces my sine is 8.6 is the amplitude sine x plus phi. And who is phi? Well, phi is tangent inverse of b over a, in our example 7 over 5. So you divide the coefficients in front the cosine divided by the coefficient from the sine, and you compute that, and the answer is 0.95 radians. Okay, if you want to express in degree, it's easy. Divided by pi and multiplication by 1. So this is 0.95. This is the thing I try to illustrate in decimals. Okay, this weight and this weight is the same, it's equivalent. And using cosine is similar, very, very similar, except it's doing the same problem, but using cosine, generalized cosine. It's the same, the formula is similar. The formula is c is equal to square root a squared plus b squared. Phi 1 gets different angle to the phi is tangent inverse of a over b. It's a reciprocal, or cotangent inverse. It's the same. So now c is the same, 8.6. Phi 1 no. Phi 1 is tangent inverse of phi. Well, let me see. Yeah, phi over 7, okay, 0.62. So you write one more time, phi sine x plus 7 cosine x is equal 8.6. Now cosine, generalized cosine x, pero minus 0.62. that this expression is equivalent to this expression, and this is equivalent to this expression. This is the same. Look, same, no, same, same, and same. The most important, I want to say to finish is when you adding sine and sine in different frequency, suppose this idea, this frequency and this frequency, the sum of this non-sinusoidal way. Non-sinusoidal. Non-sinusoidal means que es no sine, no cosine. It's a weird. However, when you're adding sine and sine of the same frequency, the answer that you get, okay, is the same frequency, but change the amplitude and change the phase shift. According to this mathematical law. Let me enclose in the box this formula for the sine. This formula, by the way, is the same, but change phi 1 and cosine. And cosine is minus, and sine is positive. End of story. You see maybe in your life application of this in physics. Okay, entonces now we start review next time, okay? Super.
Yes, Professor.
See you next time, Thursday, okay? We are doing review.
Bye-bye.
Bye-bye.
Thank you.